This is the first one, all of it, worksheet 5 8. And in all honesty, I'm going to try to do 15 minutes of this on one video. I might not make it. Consequently, you're going to want to slow it down and stop it. Look at the problems and then move along. I've got an example problem in the front, which seems obviously enough for you, but the point is, what is it you can do, and what do you think you can do, right? That's what we're trying to go for. All right? So with that in mind, and no ado, let's get started. Okay, so sketching a graph of the rational function. So we're going to start off with the function itself. Function itself looks like this. X squared minus 2x plus 4 all over x minus 2. Okay. Now, some things we can figure out how to do without actually doing the derivative or the second derivative. Some things we know how to do. For example, we know, sometimes we know if you plug in 0 for y, okay, plug in 0 for y, you should be able to figure out what x is. That would be really hard to do in this case because that would be quadratic. But if I plug in a 0 for x, that's easy enough to do. Plug in a 4 over a negative 2 gives me negative 2. So now the point 0, negative 2 exists on this graph that I'm getting ready to graph. Oh, it's the point we're trying to graph this thing. Next thing I could do is I could say, well, do I have any vertical asymptotes or holes? Well, this means that x minus 2 equals 0, so x equals 2 is a vertical asymptote. So now I know I have one spot on my graph and I have a vertical asymptote on both of those things. Next on my list of fun, festival fun, what else could I do? I could figure out how to, the limit as x approaches infinity of x squared minus 2x plus 4 over x minus 2. You may use the tallest rule, or you can use divided by the highest part of x times the common rule, which in this case would give me limit as x approaches infinity of 1 minus 2 over x plus 4 over x squared all over 1 over x minus 2 over x squared. Anything with a 0 at the bottom goes away, so it becomes 1 over 0, which means it's approaching infinity. We do the same thing with the limit as x approaches negative infinity. I get the same drill as before, although in this case, I would find out it's approaching negative infinity. Why? Because the top is positive and the bottom is negative, so it's approaching a negative value. Okay, so that should be all review. Hopefully it is. If it isn't, then pause, take a moment, get better, and come and talk to me. Those options. Okay, so those are some things I can figure out based on just the original function. Agree? All right, next up would be, what would I do? What could I do if I was just trying with the derivative? Well, the derivative, the function itself is this, x squared minus 2x plus 4 all over x minus 2. So the derivative of that would be, the quotient rule time, that would be x minus 2 times 2x minus 2 minus x squared minus 2x plus 4 all over x minus 2 squared. Keep going to simplify it, and I'm going to get 2x squared minus 6x minus x squared plus 2x minus 4 all over x minus 2 squared. And then I'm getting a little more work here. And again, if you need to pause it, slow it down, make sure you know what I'm doing. That's fine. I get x squared minus 4x minus 4 all over 2 minus x minus 2 squared. Check something quickly here. What did I do wrong? Oh, I missed my plus 4 here. Minus 2, that's minus 2 would give me a plus 4 in the middle here. So those two cancel out, that goes away. All right, so now I'm feeling good about what I got. Okay, so now, what can I figure out from this equation? What's increasing, decreasing, or maximum, minimum zone? How do I do that? Well, I do that by setting the top equal 0, define critical points, and setting the bottom equal to 0. Define critical points. Say top equals 0, I factor this out like I'm supposed to. get x equals 0 and x equals 4. Set those equal to 0, I get x minus 2 equals 0, I get x equals 2. So my critical points are at 0, 4, 2, and 4, which means I am increasing or decreasing from negative infinity to 0. X equals 0 might be a maximum minimum. From 0 to 2, I am doing something else, or possibly the same thing. Then from 2 to 4, and then x equals 4, and then 4 to infinity, something else. How do I figure what I'm doing? Remember, I just pick a point between 0 and negative infinity and plug it into my first derivative, which would be here. So I'm going to plug in, I'm going to find my first derivative at negative 1. If I do that, this becomes 1 plus 4, so that becomes 5. 5 has to be positive because it's squared, so it's positive, so I am increasing. All right? From 0 to 2, I'm going to pick out a point. I'm going to pick out 1. Put a 1 in here. That becomes negative 4. That's 1, so the whole thing becomes negative. So I have to be decreasing. It says it's going from increasing to decreasing. At the top of that has to be a maximum. Relative or absolute, there has to be a maximum there of some sort. Okay, if the point number between 2 and 4, I'm going to pick the number 3. That gives me 9 minus 12. That's negative. Bottom still has to be positive, so that's also decreasing. So I don't have a maximum or a minimum there. I have a neither. Okay, which makes some sense because on the previous page, we found that that was a vertical asymptote at x equals 2. All right, moving forward, from 4 to infinity, I pick a number like 5. That gives me 25 minus 20. That's 5 on top. That means positive, so it's increasing. Since I'm going from decreasing to increasing, that would be a minimum. Minimum. All right. With all that in mind and scratching my head, I now have some information in the first derivative. Okay? Well, that's nice. We also have a second derivative, so let's keep going. So let me see here. The first derivative is that, right? So now I'm going to get going. So then the first derivative was this. X squared minus 4x all over x minus 2 squared. So to find the second derivative, I'm going to have to use a quotient rule again. To do that, I'm going to move my x minus 2 squared to the top times 2x minus 4 to the top minus the top times the derivative of the bottom, which would be 2 x minus 2 times the change of 1 over x minus 2 to the 4. Now I'm going to recognize that the x minus 2 is found in all these. So I'm going to go ahead and get rid of that one, make this a 3, and I'm going to get rid of that one. Okay? Now I'm going to simplify from there. Here we go. So I'm going to second derivative would therefore be equal to, got to foil this thing together, so you get 2x squared minus 4x, which is minus 8x. That's 4x minus that, and makes sense, plus 8 minus, I got 2, so I got 2x squared. I got 2 times this, which is minus 8x, but the plus, that becomes plus 8x, all over x minus 2 to the third. I notice that that cancels out with that cancels 8x. Yeah, 8x, and so 8x, and so I end up with 8. So my second derivative is going to be 8 over x minus 2 to the third power. Okay, so now that I have that, where do I find my candidates for points of inflection? Where the top's equal to 0, where 8 equals 0, that's nowhere. Or when x minus 2 to the third equals 0, x minus 2 equals 0, x equals 2. So concavity changes as I start from negative infinity to 2. From 2 to infinity, there might be a point of inflection at x equals 2. All right, so now I go ahead and pick a point between negative infinity and 2 and plug it into my second derivative. So the second derivative at 0 would be 8 over negative 8, which is negative 1. So I get concave down. Remember, we're talking about second derivatives. We're not talking about increasing or decreasing. We're talking about concavity. Okay? And then, so now I'm going to do the second thing, which is, so now I'm going to figure out a number bigger than 2. So I pick 3. I pick 3, I get 8 over 1. That's positive. So I'm concave up. All right? And now I have all the pieces I need to put together a table of what's going on. Specifically, I know my x values, my f of x values, also called y values. I got my first derivative. What does it tell me? And my second derivative. What does it tell me? So here we go. So at infinity is the first. Oh, infinity is the first place of interest. Then I have from infinity to the first place I run into something interesting, which is at 0. Then I have x equals 0 is interesting. I have 0 to 2. And nothing at all. Get out of the way. Okay. Then I've got from I got x equals 2 is interesting to me. I've got 2 to 4. I've got x equals 4. I got 4 to infinity. And I've got infinity. All those places are of interest to me. So now I go back. Then I get that I have a vertical asymptote at 0. I'm at negative 2. I have a vertical asymptote at 2. Okay. So, that's the wrong way. Okay, so at 0, I'm at negative 2. At 2, I have a vertical asymptote. Those are 2 bits of information that are useful to me. I also have, looking at that same paper, that same first page, I have that I have at infinity, as I approach infinity, my function approaches infinity, and as I approach negative infinity, I'm approaching negative infinity. Fair enough. Okay, moving forward. Just time to go ahead and left. Don't get all. Okay, moving on. Okay, so then I go back to my first derivative. First derivative tells me I'm increasing from negative infinity to 0. So I'm increasing from negative infinity to 0. So this is increasing. Then I check it again. I am decreasing. We know this is a maximum. This is decreasing. Then I'm decreasing some more, and I have I don't know what there. Oh, but it's a vertical asymptote, so that makes sense. Okay, and then I am increasing after this. That makes this a minimum, whatever it might be. Fair enough. Moving on. Second derivative. Second derivative talks about concavity. Concavity, I'm concave down all the way up to 2, and concave up afterwards. So I'm concave down, concave down. I am can't even write it down. Then something weird happens here. I am concave up, concave up, concave up. Now I'm ready to draw a graph based on that information. This on my way, thank you. I'm going to draw a graph. Here we go. So using that table,